Over the last few years, technology has advanced at an incredible rate, but one thing that is lagging behind and hasn't changed is how we interact with computers. It's been mice and keyboards for decades, and frankly, this system is out of date. I want to just be able to look at something on the website and have it work. I want to be able to click buttons just by looking at them. So in this video, I'm going to show you exactly how to do that, how you can create and program a website that uses your eyes to control it. This is the future. Welcome back to Web Dev Simplified. My name is Kyle, and my job is to simplify the web for you so you can start building your dream projects sooner. So if that sounds interesting, make sure you subscribe to the channel for more videos just like this. Now right here, I have the final working version of our project. It's just a really simple prototype to really show you how you can use this eye tracking in order to run your website. And as you saw right there, my hands are right here, but currently the website is doing things, and this little red dot that you see is tracking my eye movements. Right now it's not super accurate because I'm looking at my webcam and not my screen, but what happens essentially if I look to the left, it'll swipe the picture to the left, and if I look at the right, it'll swipe the picture to the right, just like a Tinder style application. So with my hands right here, I'm going to look at the center of my screen, I'm going to look to the right, we can see it move to the right, now I'm going to look to the left, you can see it move to the left, and I can do that over and over and over again. So I'm going to show you exactly how to build this system where you don't even need to use your hands, you can control the entire website with just your eyes. Now to get started, I have a completely blank Visual Studio Code project open on the left side of my screen, and on the right I have a library called webgazer.js open. And this is the library we're going to be using to track your eye movement, and this was actually developed at Brown University. This library currently doesn't have the best documentation, so I'm going to try my best to explain it to you as simply as possible, but luckily the interface for working with the library is really straightforward and easy to use. So in order to get started working with WebGazer, you can either download the source code or you can import it using npm. I had a bit of issue using the npm package. What I'm going to do instead is scroll all the way down to here where it says download webgazer.js, click this button, and it's going to open up the file here. I'm actually just going to use this URL as inside of a script tag instead of actually importing and downloading the file and then saving it locally. It'll just be easier to work with. We're just going to copy that URL. We're going to create an index.html file. Exclamation point enter to generate this boilerplate code. And then I can just put a script tag here, which has that source. I'm just going to make sure I defer this. And if you're curious why I'm using this defer attribute, just check out my complete video. I'll link it up in the cards and description. It'll explain it all the way in depth. Also, I want to import another script here, which we're just going to call script.js. I'm also going to defer that. That's where all the code for our application is going to go. And inside of our body, we really don't need anything. Everything is going to be in JavaScript for this project, so we can just leave all this blank. It's fine. So then let's create that script.js file, and in here is we're going to write all of our code. Now to get started with this library, it's actually super straightforward. We can just say webgazer, which is a global variable that's imported from this library. And we can tell it that we want to start listening. So we can set a gaze listener, and this gaze listener essentially just takes a callback function. This is going to be called every single time that it makes a prediction of where you're looking at on the screen. And it's going to pass you data for that prediction, as well as a timestamp when that prediction actually occurred. So that way you can tell how long it's been between different predictions. And then in order to start this running, we just call this begin method on our WebGazer. Now in here, we can just console log out our data and our timestamp. And if we just run this, you're actually going to notice we get a really strange error being thrown. So I open up this with live server, wait for it to load up over here. You're going to notice we get a warning essentially saying WebGazer works only over HTTPS. If you're doing local development, you need to run a local server. And if we just click OK, you're going to notice it actually works completely fine like this. I think it's just because some browsers require you to use HTTPS even when you're doing local development, but Chrome in this case does not. We can actually inspect the page here. If I pull over my console, we go over to the console section. You can see right now we're having this being printed out saying null, as in it doesn't have a location where I'm looking, and then it has the timestamp of this prediction. And in order to get this to start working, you just have to click on your screen. That is essentially going to save a data point inside this model, and it's going to start training this AI model. Every single time you click, it's assuming you're looking at your mouse when you click, because most likely you're going to look at what you click. So it's saving that as a data point. So if I just click on the screen and look at my mouse, you can now see this red dot on the screen, which is trying to track my eye movement the best that it can, but it only has one data point to work on, so it's not super accurate. So to calibrate this, what you want to do is just kind of go to the corners of your screen, look at it, and click a few times in each one of your corners. And if I just do this a couple of times, you're going to notice that eventually it's going to start to become much more trained. So I'm just going to go all the way around the corner here, looking at my mouse and clicking on this over and over and over again. This is just to try to calibrate these sensors. And we'll finally come up here and we'll just do the center here. And now without me touching the mouse, I can look all over the place, top, bottom right down here, bottom left, top right, and it's going to try to follow that the best that it can. And depending on your lighting scenarios and your webcam, it's going to follow it better or worse. It really depends. But it's trying to follow the best that it can. And over on the left, it's trying to print out that position. You see we have an X and a Y. Kind of hard to see, but if I just come in here and I minimize this, it's going to stop running in the background. So we can see we have an X, a Y, some features related to the I, and then this all array, which just has our X and Y position. Really, all we care about is X and Y because that's actually determining the location of where we're looking. Now, one thing you'll notice though is if I refresh this page, I'm going to get that warning again. Don't worry about this. If you want to get around this, you can use Parcel and bundle it with Parcel. I have a video on Parcel I can link in the cards for you, but it really doesn't matter for our use case. You're going to notice though that when I refresh here, once everything loads back up, if I inspect the page, look at the console, you're going to notice it's still printing out null. It lost all of the data we used to train it. We want to be able to save that data and persist that data between each iteration so that whenever we refresh our page, come back on a different day, close our browser, open it back up, we want to save that data we've trained so that way we don't have to recalibrate every single time. And luckily, there's a really easy way to do that in this library. We just come in here and type window.save data across sessions, set that to true. Now it's going to save all of our data inside of essentially IndexedDB, which is very similar to like local storage. So if we just save that again, hit OK for this warning, inspect our page, go to our console. Our console here, you can see that it's now being able to track everything, and we can calibrate this. I'll click up in this corner, click a few times up here, over here. I'm sure it's really fun to watch me do this, but it makes it a little bit more accurate if I just do this calibration real quick. And generally, if you're working on your own site, your users are going to be clicking where they're looking a lot of the time. You don't have to worry as much about this calibration step because the users are going to naturally calibrate the software themselves. And as they use your site more and more, it's going to become more and more accurate where they're looking. This may not be the most accurate because I was talking to you, moving my head a bunch when I was talking, but if I just don't move here and I look to the right, you can see it's on the right side, look to the left, it's on the left side, looking in the center, it's in the center. It's not super accurate, but for our use case, it's accurate enough. So let's just close out of this here. We don't really need this open. And what I want to do is work on getting images loading into the center of our screen so that we can move these images around left, right, and make them slide off the page and stay on the page. So what I want to do in our index.html is first create some styles so that we can style our image to fill this section of our screen and also make it move to the left and to the right when we swipe it left and right with our eyes. So the first thing we do, create the style tag here, and I want to style our body first to get everything in the center. So we can just say our margin is 0. We want to set the display here to flex. We want to justify our content in the center. We just want to hide any overflow. This is going to make it so that when we slide our images left and right, they don't create scroll bars because they go off the screen. They're just going to be completely hidden. Now I want to style all of our images. I want their width to be 50% of the width of my screen, and I want the height here to be 100% of the view height. The images are kind of look a little bit ugly, but it really doesn't matter. For our use case, this is just a temporary placeholder kind of showing you how this works. It doesn't have to look beautiful. Also, to make it give that slide effect, I'm going to create a transition. I want this transition to be on the transform property, and I want it to occur over 200 milliseconds. And if you're curious why we're using transform, I have an entire video covering CSS performance and animations. You can check that out. I'll link it in the cards and the description. Now lastly, to make it so that our image looks a little bit better, we're just going to set the object fit here to cover, so it's not going to be stretched out and super pixelated and off aspect ratio. Now if we want to move our image off the left side of our screen, we're just going to take our transform property, which we're transitioning, so it'll animate this property for us. We want to take the translate in X direction and move it -100 view width. So essentially it's going to move off the screen completely to the left side. And the same exact thing we want to do for the right. And instead of using negative here, we'll use positive because we want it to move off the right-hand side of our screen. And now lastly, we're going to create a little bit of an interesting class here called the next. And all I want to do here is set the display to none. The reason for this is that I want to preload each one of our images so that we have the current image that we're showing, and then I want to preload the next image directly behind it. That way, once we swipe one image, the other one is immediately loaded. We don't have to wait for it to become loaded because loading large images could be slow, especially on a slow connection. So with that done, that's really all the styles that we're going to need for this. So we can move into our script.js file. Now in here, I essentially want to get our current image as well as the next image, and I'm going to store those in variables. So we're going to have a variable called image element. We're going to just call a function called get new image. We're going to do the exact same thing for our next image element, but I'm going to pass in here true because I want to say that this is going to be our next image. That way we can distinguish between our current image and our next image. These are both variables that we're going to modify throughout the course of this application. Well, let's just create that quick function here. So we can say function get new image, and this is going to say true false for whether it's next. And by default, we'll just set that to false. So then inside of here, we want to create that new image. So we'll say we're going to create an image. So document.create element of image. And then down here, all the way at the bottom, we want to append this to our body. So we can say document.body.append image. And if we just save this and don't do anything, you're going to notice that we have two images being appended to our screen, but they don't have any source right now. They don't actually do anything, so we just have two images. That's why you kind of see this weird line here. Technically, we have two images on our screen side by side. Now, obviously, I want to give these images a source, so we can say image.source. And to get a random image, we're going to use a site called Pixum. So we can just say in here, pixum.photos/1000. This just tells it the size. We're going to say 1000 pixels, plenty large for our use case. And then if we just do this, we're going to get the same photo back every single time because it's going to cache the result of this call, and we're always going to get the same photo. So to prevent this caching, all I want to do is append something random to the end, so that way we have a different URL every single time. So if I just put math.random at the end of our URL is going to be different and stop us from having to deal with that caching problem. So now if I save, just click this OK to not have to worry about this, you're going to notice we're still not getting our images. It looks like I just spelled photos wrong. So if I spell that correctly and save, hit OK, we now should get two separate images. And as you can see, we get two completely random images. If I refresh the page, hit OK again, we'll get two other completely random images. They're just completely random from this Pixum site, so who knows what we're going to get. But it's great because it allows us to kind of simulate that idea of like a Tinder-like interface where a new image is showing us every single time that we swipe the old one out of the way. Now the next thing I want to do is hide the next image, because right now I only want to show the current image. And as soon as the current image swipes off our page, then we'll show the next image. So we could say if next, then what I want to do is just take our image dot class list, and I want to add that image next, or that class next, which is going to hide this for us. So now if I click OK, we should have only one image being shown up because the next one has this class next, which hides it from us. And then we add it to the body. And finally, I want to return the image down here, just so up here, we can actually have access to the image and use the image to remove it from the page or swipe it to the left and right or whatever we need to do. So now if I save that, everything should be working and we have references to our current image and our next image right here. So we can use them inside of our gaze listener to swipe to the left or to the right. Now the next step is to actually work on the code that's going to set up this gaze listener to determine if we're looking to the left or to the right. And for our purposes, what I want to do is if I'm looking on anything in this white section to the left of my image, essentially the left quarter of my screen, I want to swipe to the left. And if I look over here on the right-hand side in this white section, which is the right quarter of my screen, I want to swipe to the right. That way the area you can look is large enough that even though there's slight inaccuracies in this algorithm, is still going to be close enough that we can see this large area and determine we're inside this large area and not just a small little button. Because like I said, this is not the most accurate algorithm. So to do that, we need to determine where these borders are. And that's actually luckily pretty easy. So we'll create some constant variables. We'll call this first one left cutoff. This is going to be essentially the line where our image ends and this white section starts. This is just 1/4 of our screen because our image is 50% of our screen. So this left side is 25% of our screen. So if we just take the inner width of our screen, our window, and we divide that by 4, that's going to give us the exact pixel where our image and our white section meet on the left side. Now I want to do the exact same thing, for the right cutoff, but instead of it being here divided by 4, what I want to do is take the window.inner width and I want to subtract it from 1/4 of the width. That means that we're going to get this line right over here where our image turns into this white section on the right side. So now we have the pixel values for where our cutoff is. So if we're looking left of this left cutoff, we swipe left. If we're looking right of the right cutoff, we swipe right. But one problem is, even if I'm looking dead center, every once in a while, the thing is going to move off to the right section of either side. It's going to be kind of random because like I said, there's slight inaccuracy. So sometimes it's going to look you really far to one direction or the other. And we don't want to accidentally swipe someone to the left or right just by instantly looking in that direction. So what I'm going to do is set up a delay. Essentially, we have to look directly to the left or to the right for a long enough period of time for it to actually recognize that we want to move to the left or the right. I'm going to set that delay for a second. So if you spend an entire second looking all the way to the left or all the way to the right, it's going to swipe the image for you. So we're just going to say our look delay is going to be equal to here 1000 milliseconds, which is the same as 1 second. So this is our 1 second delay. We have our left cutoff, our right cutoff. Now we can use our data, which has an X and Y value, to determine if we're left of the cutoff or right of the cutoff, and also make sure we look in that direction for long enough. So we can really simply just come in here and say if data.x is less than our left cutoff, then we're looking to the left. Else, if our data.x is greater than our right cutoff, then we're looking to the right. And then finally, we're going to have another else if down here. And this one is just going to say if our x is greater than or equal to our left cutoff, and our x is less than or equal to our right cutoff, that essentially means that we're looking in the dead center. So we can determine if we're looking at the left side, we're looking at the right side, or if we're looking down the dead center. And in here, we can manipulate some variables to determine when we start looking to the left, when we start looking to the right, and also figure out if we looked there long enough or not. So I want to create yet another variable. And this variable here is just going to be called our start look time. And I want to just set it to a really large number. So we're going to say the positive infinity. This is the largest number possible. That's just going to be our default value. And this is essentially when we start looking either to the left or to the right. We can set that based on this timestamp here. So if we look to the left, which our data x is less than our left cutoff, then I just want to take our start look time and set it equal to our timestamp. And I want to do the same thing if we're looking off to the right-hand side. So whether we look left or right, I want to set our start time equal to the current timestamp. Otherwise, down here, I want to set it to this positive infinity. So I can say start look time is back to positive infinity, essentially restarting our timer because we're looking in the center, and that means we're no longer looking left and we're no longer looking right. Now down here, what I can do, I can say if that start look time plus our look delay is less than our current timestamp, then that means that we've looked in that direction for 1 second, because we're taking the timestamp of when we started looking, adding our 1000 millisecond delay, and checking if that's less than the current timestamp. If it is, then that means we've been looking in that direction for a total of 1 second, which is long enough for us to do this swiping action. Now, inside of here, we can just simply say console.log here just to see if this would work. And unfortunately, it doesn't matter what we do. This code right now is not going to work. I can come in here and inspect our page. I can go over to the console, and I can just come and look to the left. Actually, we have an error. It says cannot read property x of null. That's just because our data is starting out as null. So if our data equals null, then just return. Essentially, we don't want to worry about null data. We only want data that has an x or a y. So now, if we inspect our page, and we go to the console, you can see if I'm looking to the left, or let's just look at the right. I'm looking at it for a long period of time, or I'll look at the left for a long period of time. You can see I haven't left that white area on the left for a long period of time. It doesn't print here at all. And that's because we're constantly resetting our start time because we're constantly on the left side. What I want to do is to be able to determine if we've already started looking to the left and then don't reset the timer at all. Just skip everything in here if we've already been looking to the left. So to do that, we're going to get a variable called our look direction. And this by default will just set to null. And in here, we're going to set our look direction to left. And then up here, we just want to say if our look direction is not already left, then we come in here. But if we're already looking to the left, don't worry about it because we're already looking that way, so we don't want to reset our timer. Same thing here. We're just going to do it for the right. So if it's not equal to right, and then in here, we're going to set our look direction to be equal to right. Just like that. And then finally in here, we're going to reset our look direction. So let's say look direction is equal to null because this is, we're looking at the center. We want to just reset everything when we look at the center. So now if I just click OK here, make sure we inspect our page again, go over to the console and just wait for it to load up, back to the console again, clear all this. Now if I look to the left, hopefully we'll see it prints out here. As you can see, it's printing over and over again. And the same thing, if I look over to the right-hand side, you can see hopefully it started printing here again. I can't see because I'm looking to the right. It's kind of hard to see, but either way, hopefully it worked. And now we can just close this out. So we know that this is working. When we look at the left for a second or to the right for the second, it is printing out here, which is great news. Now the next step is to make the image actually move. So we can say if our look direction is equal to the left direction, then we can just take our image element and we can take the classes and we can add the class of left. This will move our image to the left. Otherwise, obviously, if we're not looking left, we're looking right. So we want to add the class of right. Let's just see if this works real quick. So I'm just going to look to the left and hopefully the image will move to the left after about 1 second. So once all this loads up, I'll look to the left. And as you can see, the image swiped off to the left-hand side. So just by using my eyes, I was able to control where the image moved. Now the next step is to show the next image and make sure everything else essentially resets itself. Because if I keep my eye to the left, I don't want to swipe the next image and the next image and the next image repeatedly. I want to make sure I reset myself to the center and then back to the left to reset everything. So in here, I just want to reset all of our variables. So we can say our start look time is now back to that number dot positive infinity. Oops, positive infinity. And our look direction here, we're going to set to something interesting called stop. Essentially, I want to stop caring about where I look. So up here, if the look direction is equal to stop, then I just want to return. I don't care what's happening because the next image is loading, so I don't want to worry about where I'm looking. If we're loading, don't worry about where I'm looking. Now I want to load in that next image. Now I'm actually going to do that in a set timeout because the current image is in the middle of an animation and we set the animation time to 200 milliseconds. So I want to wait for that animation to finish. So after a 200 millisecond delay here, then we're going to run the code that removes the old image and starts up the new image. So we can remove the old image. We can take the next image, next image element. We can get the class list and we can remove that next class so that it is now visible. And we can move around our variables. So now our current image is our next image, and our next image is just going to be equal to get new image. We're going to pass in true here. And then I want to say that I want to reset my look direction because now that the new image is loaded, I want to start caring about where they look, but I want to first make sure they look at the center of the screen before looking left or right. That way it is guaranteed that they don't accidentally just continue looking left and just have images fly by them over and over again. That's what this reset does. We need to implement that up here by essentially saying that if the look direction is equal to reset, we don't want to run the code in these sections. So if we're looking to the left and the direction is not left and the look direction is not equal to reset, then we can do this code. I want to do the same thing in here. I want to say, and the look direction is not equal to reset. Essentially, this just means that we won't accidentally continue looking left or right and just have things fly by us. It'll force us to look in the middle to reset everything. Because this doesn't care which way we're looking. It'll always reset when we look at the middle, and this look direction will be null, which will no longer be equal to reset. So if we save this, it's going to reformat my code a little bit. That's perfectly okay. But now if we click OK, and I look, wait for everything to load up, of course. And now I look in the middle of the screen. Now let's look to the left side of the screen. You can see it swipe left. I'm going to look to the right side of the screen. A little bit harder. The calibration is not as good, so I'm going to try to calibrate it over to the right. Looks like that's not actually working, so maybe there's a different problem. Let's go to our console and see. And of course, it says type error look direction is not a function. So somewhere I'm calling look direction, of course, right here. I don't know why I did that. It's a variable. Should set it to a value, not call it as a function. So now, hopefully, this actually works. Let's just wait for everything to load up. There we go. So look to the left. Move to the left, look to the right, move to the right, and then back to the left. You can see it move to the left. And every single time I have to look back at the center, because if I just hold my eyes over to the left-hand side, we'll just try that real quick. I'll look in the top left here. And I just keep my eyes here. You're going to notice it's not going to swipe the next image until I look to the center and then back to the left. Then it'll do that reset code, which is really important to make sure images don't just fly by. Now, one thing that you obviously don't want your users to see is this weird face where it has all the dots, and you don't want to see the red dot of where you're actually looking. That's confusing to a user. It's not going to make sense to them. We want to hide these things. Now, to hide this is actually fairly straightforward. We'll just come down here a little ways, and all we want to do is say webgazer.show video preview. We're going to set that to false, and show prediction points we're also going to set to false, and essentially that's just going to hide all of that for us. So if we just click this warning again, let it all load up, it's going to take a little while for the camera to boot up and load, but once it does, you're going to notice the camera doesn't show up here. There's no red dots, but I can still look to the left. It moves. Look to the right. Look to the right, come on. Well, if I look back to the left, it's moving. The right side is not as calibrated as I would have hoped, apparently, but I'm also on half a screen. My webcam is not in the best position. There we go, I got the right side to work. Back to the left. There we go, and you can see that it's working. It's a little bit harder for me to get feedback of what's going on because I don't have the red dot, and obviously on a small screen like this, it's a little bit harder to be accurate, but if you're on a full screen, it's much easier to get it to move left or right. And that's all it takes to control the web with your eyes. If you enjoyed this video, make sure to check out my other videos linked over here, and subscribe to the channel for more videos just like this. Thank you very much for watching, and have a good day.